Hey guys, welcome again to the Maths Club. If you're just joining us, so welcome. Continuing our series on mensuration, we're going to look at surface areas, volumes of cones, spheres, and hemisphere. If you have not subscribed to our channel, this is a good time to actually do. We've noticed that a lot of viewers don't subscribe. Help our ministry as we're trying to help you understand maths. Let's get started. Solids and surface area. A solid is a three-dimensional shape, and the surface area symbol A of a solid object measures the total area that the surface of the object occupies. So we discussed this in the previous video. I'm just reiterating it. And surface area is measured in square units. We said for two-dimensional shapes, area is calculated. For three-dimensional shapes, we talk about total surface area. So for a cone, what is a cone? It's basically a solid with circular base and slant sides. Can be created by folding the sector of a circle. You know what a sector is. If you fold it, you can get a cone, or by considering a standard right circular cone. So this is basically what the cone looks like. You see the circular base and you see the slant sides or the slant heights. So this point is the vertex, which is the topmost part. This is like the axis, which divides it into two equal halves, right? So this line here, the angle here and the angle at this other side, they're going to be equal. You see, this is the base, this is the center of the circular base. From here to here is the radius. So you can see it forms a 90 degrees with the axis. So this is the axis, this is the radius, and this is the slant height or slant side. This is when you're considering a standard right circular cone, this first guy. But we know we said we can fold the sector of a circle. So this is like a sector of a circle. If we fold it, you can see we can get this back, and similar to what we have here. So this is a cone, and this is our right circular cone. For the curved surface area, there's something you just need to know. The formula for the curved surface area is pi RL, L, which is the slant length. The volume is 1 over 3 pi r square h. Do you know when I try to take the volume? I have a cylinder like this, and in that cylinder, maybe there's a circle of axis. So just draw something like this. Great. These are how I always pick it. So you can see this like side. So if I wanted to do this like side 1, side 2, side 3. So this part here, which is like our cone, right, is just one side or one division out of these three divisions. So know that the volume of a cylinder basically is pi r square h. But because if you look at the cone, this is how I pick it to. I don't know if that's the correct interpretation, because the cone here is just taking one part out of the three divisions. So I'll just say the volume aspect just be 1 over 3 of the volume of a cylinder. So that's how I actually always remember the formula. So 1 over 3 pi r square h. That will give me the volume of a cone. So we also know that from Pythagoras, because there's a right angle, the L squared is equal to h squared plus r squared. I mean, so if you're trying to find any of all these sides, maybe the L, you can be able to use this formula if you have the other two guys. And then for the total surface area, I mean, there's the circular base. You have to find the area of the circular base, and then there's a curved surface area, which is like this top here, right? This top. So you have to add both of them. This is pi r square, and we said the curved surface area is pi RL. So by the time you add both of them, you should find your total surface area. Of course, you can factor out pi r from both sides. Let's an example. Example says that the volume of a cone of height 9 cm is 1848 centimeter cube. Find this radius. Take pi to be 22 over 7. This is taken from WAEC 1992. As always, I encourage you to pause the video and try it out yourself before you play it. So we are told that the volume is 1848 centimeter cube. We're told that the height is 9 centimeter, and we're told to take pi to be 22 over 7. This is our given, right? So we know the formula for volume is pi r square h 1 over 3, right? I know this because I always picture that cylinder. So let's substitute. That will be 1848 is equal to 1 over 3 times 22 over 7 times r squared times 9, right? So 3 here 1, 3 here 3. So this 1848 is equal to 66 r squared all over 7. If I cross multiply, that will be 66 r squared is equal to 1848 times 7. If I divide both sides by 66, what would that give me? That will give me my r should be, or my r squared should be 196. Right, so if I take the square roots of both sides, my r will just be square root of 196, which is equal to 14. So 14 centimeter. So my r is 14 centimeter. That is option B. Great. Example 2 says that what is the total surface area of a solid right circular cone of base radius r centimeter and height r centimeter? So in this question, what are we given? We are told that the radius is r centimeter and the height is r centimeter. So if these are cone, right, this is the height h, this is the radius r, and this is the slant as l, right? So our total surface area formula is going to be area of the circular base, which is the area of the circle, plus the area of the curved surface, right? The curved surface on top. So we need to find this, which is pi r squared plus pi rl, right? We could just say this is pi r open bracket r plus l. In the question, we're given the r, we're given the h, but we're not given the l. But we know that from Pythagoras, l squared is equal to h squared plus r squared, right? And the l squared is, the h is r, so that will be r squared, and our r, which is radius, is also r, so r squared. So our l squared is equal to 2r squared, and if I take square roots of both sides, right, our l will just be equal to square root of 2r squared or r root 2. So we have this. Now if I substitute, so substituting, our total surface area is equal to pi r open brackets r plus r root 2, right? If you notice, this is r, we can factor out another r from these two guys, so that would be pi r times r open brackets 1 plus root 2, right? So this is pi r squared 1 plus root 2 centimeter squared. So this is how we solve this question. That would be option B. Great. Example 3 now says that find the volume of a cone whose base diameter is 12 centimeter and the height is 9 centimeter. Leave your answer in pi. This is VTR 2013. I encourage you to pause the video and try it out yourself. So we're trying to find what the volume is. This is basically what we're given, and we're told that the base diameter, the diameter of the base is 12 centimeter, the height is 9 centimeter. We know volume of our cone to be 1/3 pi r square h. So we need the r, so the r is d/2, which is 12/2, which is 6 centimeters. So if I substitute, right, so I could just say substituting, our v is 1/3 times pi times our r, which is 6, that will be 6 squared, times our h, which is 9, 3 so v is equal to pi times 36 times 3. Our v is equal to 108 pi centimeter cube. Always put your units. So that means our answer is option B. Great. So now we have our circle, right, our sector of a circle curving to become a cone. Remember, we talked about this. What's neat is that this place here, let's assume that this is our big letter R, which is radius of the sector. So if this guy here is big letter R, taken as 21 centimeter, this guy here will become the slant height. Try it out. Take something that is like this and bend it to form a cone. Use that the radius, right, this radius here, this radius here, this radius here will become the slant height. This circular portion of the sector, right, will become the base circle by the time we fold it. So what you notice is that, this base sector has its own radius, right? So this radius R is different from this radius R. This one is coming from the sector, this one is coming from the circle that will be formed when you join these two ends, this end here and this end here. Great. Given that, we know that the length of arc, this guy here, the length of this arc here is length of arc, will become the circumference of the base of the cone, right? Remember, this is a circle, and for a perimeter of a circle, we say it is called the circumference. So the length of the arc here will become the circumference of the base of this cone. So what we have here will be length of arc is theta over 360 times 2 pi r. This area being the radius of the sector, right? The radius of the sector is equal to 2 pi r. This area being the radius of the base of the cone, or the base circle of the cone. So given that, we can be able to find our r, which is the radius of the base of the cone, to be theta r over 360. So this is just basically showing the difference between the radius of the base of the cone and the radius of the sector. So given that, we know that from Pythagoras, the L, which is the slantlet, the square of it is equal to the h squared plus the r squared, right? The r, which is the radius of the base of the cone. So we can find h squared by making simple formula, and we can find h. Then we are substituting, because what do we know as our r? We know our r to be theta big R all over 360. So if I just plug that in, you can see that your h is equal to square root of L squared minus theta r all over 360 all squared. An example: the angle of a sector of radius 8 cm is 240 degrees. This sector is bent to form a cone. Find the radius of the base of the cone. This is from WAEC 1992. This is a very simple question. What are we given? We are told that the radius of the sector of the circle, which is the big R, is 8 cm. We are told that the theta is 240 degrees. It's bent to form a cone. We are trying to find the small letter r, which is the radius of the base of the cone. What do we know? We said r is equal to r theta all over 360, and we showed how this is because the length of the arc is equal to the circumference of the base of the cone. From there we're able to find this relationship. So you just substitute. This is 8 times 240 all over 360. This will cancel this. 6 here 6, 6 here 4, 2 here 2, 2 here 3. So what we have here is 8 times 2, which is 16, so 16 all over 3 centimeter, because we're trying to find the radius of the base of the cone, and that will be option A. Great. Example 5 says that a sector of a circle of radius 7 cm subtending an angle of 270 degrees at the center of the circle is used to form a cone. Find the base radius of the cone and calculate the area of the base of the cone. Area of the base of the cone, basically, which is the area of the circle under, correct to the nearest square centimeter. This comes from WAEC 1988. As always, I believe that you've paused the video and tried that yourself. So the sector of circle has radius, so that means our big R is 7 cm. These are our given. The angle theta is 270 degrees, right? We're trying to find the small letter r. We're trying to find the area of the base of the cone. So for our small letter r, we know that it is r theta over 360, which is 7 times 270 over 360. 9 can go, right? 9 can go here 30, 9 can go here 40, 0 comes to 0. So what I have here is 21 over 4 centimeter. So 21 over 4 centimeter is the same thing as saying or 5.25 centimeter. So now that we know that, we can now move to the next question, which says that the area of the base of the cone. We already know the radius, so for the B part, the area of the base of the cone is just basically pi r squared, right? And that becomes 2 over 7 times 21 over 4 all squared. Great. So let's just solve this. So 22 over 7 times 5.25 all squared. This gave me 86.625 centimeter squared. But the question says that we should calculate and correct to the nearest square centimeter. So this is basically approximately, this is 6 greater than 5, so this is 87 centimeter squared. So to the nearest square centimeter. So this is how we solve a question like this. Let's see if we're correct. Great. So example 6 now says that a sector of a circle with radius 21 centimeter has an area of 280 centimeter square. Calculate, correct to one decimal place, the perimeter of the sector and then if the sector is bent such that its straight edges coincide to form a cone, calculate correct to the nearest degree the vertical angle of the cone. Take it from WAEC 2011. I assume that you pause the video and check this out yourself. So what are we given in this question? We're told that the radius of the sector is, which is the big letter R, is 21 centimeter. The area of the sector is 280 centimeters squared. We're told to find the perimeter of the sector. We're told to find the theta of the vertical angle of the cone. So what do we know from this? Area of a sector is theta over 360 times pi r squared, right? Great. So if the area of a sector is this, we can substitute this 280 is equal to theta over 360 times 22 over 7 times the r is this big letter r, so let me just say r squared times 21 all squared, right? So let's just cross multiply. So this is 280 times 360 times 7 is equal to theta times 22 times 21 squared. So 280 times 360 times 7, there's a very big value, so that's 705,600 is equal to 22 times 21 all squared. This is 9702 theta. So if I divide this one by 9702 and 9702, so this is 705,600 divided by 9702. So our theta is 72 points, let me just say 73 degrees, so approximately, right? We know our theta, so now we can find our A question, which is the perimeter of the sector. What do we know about? So now that we know our theta, the next thing to do is to let's draw out the sector. It's always good to draw out things so that you can imagine it. These are radius and these are radius. So we know that the perimeter of the sector is going to be, you have to add these two radiuses, remember, that will be 2r plus the length of this arc. Remember what our length of arc is? If this guy here is our theta, we said that would be theta over 360 times 2 pi r. So this is 2 times the radius is 21 plus 72.73 all over 360 times 2 times 22 over 7 times 21. So 2 times 21 is 42. So plus, by the time we add all these guys together, this gave me 26.668 centimeter. So if I add this plus 42, this gave me 68.6, let me just say 67 centimeter. So that's basically it for the question A. Now for the question B, it now says that if the sector is bent such that the straight edges coincide to form a cone, calculate correct to the nearest degree the vertical angle of the cone. So if you have our cone, let me just put the B here. If these are cone, remember when it's theory questions, always try to draw your diagrams. It shows that you understand what you're doing. So if these are cone and I put this guy here, so yeah, these are our heights, these are slant L, and these are our R. So this theta, let me call this guy here alpha, right? So this guy, so they're telling us to find the vertical angle of the cone. So this guy, which is the alpha, this alpha is not going to be the same as this theta. That's one thing you need to know. It's not the same thing. And let's see. So we know our L, right, which is basically the R from what we've said so far. I'll just recap it again. Where we said L squared is equal to H squared plus R squared. Then we now said that H squared is equal to L squared minus R squared, right? Then our H is square root of L squared minus R squared, right? Then we now said since this R is theta R all over 360, so this will be squared. If you remember this, so these are H, right? Now remember our L is also the same as our R, right? Because it's the cone that was bent. So let's just substitute. So that will be square root of, what is our R? Our R is 21, so that will be 21 squared minus the theta is the theta of the angle that was used to form the cone, which is 72.73 times 21 all over 360 all squared. So this square root of let's see, what's 21 squared? That is 4 0.41 minus 72.73 times 21 divided by 360 or squared. That will give you if I just say that will be 18, right? So square root of 441 minus 18, that gave me 20.57 centimeter. Of course, these are approximations. So we know the h, we know the l. We can find this first half, which is alpha over 2, right? We can find this alpha over 2, right? Because this entire place is alpha. If I have this h and I have this l, I can find alpha over 2. So this is adjacent and hypotenuse, right? So car 2, so that is car. So this cos alpha over 2 is equal to, what is our adjacent? Our adjacent is h, all over our hypotenuse is r. So cos alpha over 2 is equal to 20.57 all over 21. So divided by 21. So this would be cos alpha over 2 is equal to 0.9794, right? So if I take the cos inverse, that will be alpha over 2 is equal to cos inverse of 0.9794. So cos inverse of this guy. So alpha over 2 is 11.656 basically. So if I cross multiply, my alpha will be equal to 11.656 multiplying 2, and this will be 23.31 degrees. So our alpha, which is the vertical angle, is 23.31 degrees, and then our perimeter of sector is 68.67 centimeter. Let's see if our answers are correct. Great, but it is not entirely correct because it said correct to the nearest degree. So let's do that. So to the nearest degree, this is approximately 23 degrees because this is not up to 5. So to the nearest degree. For this first question too, we are not good too, because the question is that we should calculate and correct to 1 decimal place. We didn't do that. So this is approximately 68.7 centimeter to 1 decimal place. Please ensure that you always read the question to the end and do everything that the question is asking, because if you don't do this last part, there is a mark for it and you will lose it. Imagine doing all this hard work and losing some few marks because of you did not read the question to the end. I'm guilty of that. Please don't be. Once again, if you have watched the videos at this point and you have not subscribed, you want me to appear in your dreams, please hit the subscribe button and like the video, because if you have watched it to this point, you found value so far. Great, so we are good. Let's start talking about frustum. What is frustum? So frustum is formed when a cone is cut parallel to its base, removing the top portion. So basically you have, let me just go straight to the image. You can see, so it's cut parallel to the base. This is the base that you see. It's cut parallel to that base, then you remove the top portion. What you have there is the frustum. So it looks like the pail. I know some of you might not have noticed, but when I was in secondary school, we had these iron buckets, right? This iron bucket was a classic example of a frustum, right? Even some buckets still look like this if you turn it upside down, but that iron bucket was like the basic, was like the direct I'm sure it's from Frustum of Cone that they got that iron bucket. So the remaining shape has a circular base, right? This is the circular base, right? I mean, this is the larger one, and then you have a smaller one. So it has two circular bases, the larger one and then the smaller one. So that's basically it. Cutting a cone parallel to its base and then removing the top portion. That's basically frustum. Big word, small meaning. Example 7 now says that the diagram below shows a cone with its dimensions of its frustum indicated. Calculate the height of the cone. This is going to work 1995. Let's solve this together. So basically, right, you can see this top portion here will have been removed, right? So that's the first thing I need to know about frustum. So if I blow the image up, let me try and reproduce the image. Right, so we have this part blown off. So in this part here, there is the smaller circle, right? The radius of the smaller circle is 6 centimeter, right? The total height of this guy here is what we're trying to find, right? And the radius of this guy here is 12 centimeter. From this place here, remember, it's the frustum of the cone this top part will have been removed. This place is just for representation. I should have even done it in dash lines. It should be in dash lines to show that it has removed. So just permit me to just put a bit of dash on it so that you know this is not dash dash, but I mean take it like that. So from here to here is also 12 centimeters. So I'm trying to find the entire height of the original cone. So that means from here to here add a small height. Let's say this is x, right? So this entire height will be 12 plus x. So what we can do here is we're going to use the principle of similar triangles, which we have not yet talked about yet, but that's fine. So you can see we have two triangles. We have a small triangle here, and we have a big triangle, right? We can use comparison because I mean they share the same axis, right? You can see they are all spinning off. This small triangle is spinning off this bigger triangle. They share a common axis. You can see the axis of this guy, the axis of this guy here. They share a common axis. So if that is the case, if they share those common axes, and one of the triangles is a subset of the other one, right? This small one is a subset of this bigger one. But now say the radius of this first circle, or from here to here, which is like the base of this smaller triangle, is 6 all over. The base of this bigger triangle, right, this bigger one, which is here, is 12. So the base of the small one over the base of the big one is equal to, what is the height of the small? The height of the small here is what? X all over the height of the big triangle, right? This would be 12 plus x. Once you know this, you are good to go. So it's to cross multiply. So this is 12x is equal to 6 open bracket 12 plus x. So this 12x is equal to 72 plus 6x. So 12x minus 6x is equal to 72. So 6x is equal to 72. And if I divide both sides by 6, my x is equal to 12 centimeters. So you can see that here to here is 12 centimeter and here to here is 12 centimeter. So for the height of the cone, so let me just come here and see, therefore height of the cone, which is equal to 12 plus x, is now equal to 12 plus 12, which is equal to 24 centimeter, right? So don't be carried away and say whatever x gets is just from this guy here to this top guy, but the entire height will be 12 plus 12, which is 24, and that will be option D. Great. Example 5 now says that find the capacity in liters of a bucket 24 centimeter in diameter at the top, 16 centimeter in diameter at the bottom, and 18 centimeter deep. So these are our buckets. Let's just see this guy here. This is the bottom of the bucket, and this is the top of the bucket, and this is the part of the cone that was cut off, right? So we're told that this diameter here, the diameter is, where is it? So 24 centimeter at the top, and so this is the bottom. I just inverted the buckets. So this is 16 centimeter, and this guy here is what? 24 centimeter, and this height here is 18 centimeter, right? So from here to here is just x centimeter, right? Great. So for this guy, the diameter here is 16, diameter is 20. I can see the diameter when I'm doing comparison, right? So you can see this is similar triangle. See the big triangle here. Can you see the big triangle? This is the big triangle, right? And you can see the smaller triangle here, which is a subset of the bigger triangle, and they share the same axis. This axis, this axis, they share the same vertex, right? You can see they share the same vertex. Great. I think when we get to similar triangles, you'll see what actually makes up a similar triangle, and you will gain more understanding on that. So for me to find the capacity, right, there are different formulas that you see on the internet, right? You can say formula, I think there's 1 over 3 pi open brackets big R squared plus small r squared plus RH, no, plus R big R. You can check for that, but I always like to make things very practical and simple. Now for this bucket, you can see that there are 2 cones. There is the big cone, this big cone, right, which is like the initial full cone, and at this top place here there's a small cone that was removed. this small cone was removed. So if I find the volume of this big cone and I find the volume of this small cone, and I take out the volume of this small cone from the volume of this big cone, do you agree with that we'll have the volume of the remainder, this guy here? Yes, and that's all that we need to know. That's all. So for me to find the area of this big cone, I need to find 1 over 3 pi r square h. And for me to, so maybe this one is r1 or d1. Let me just say this d2. So this would be r2 all squared. Then the big height, let me just call this guy big H. Then I also need to find the area. This will be 1 over 3 pi r1 all squared, small letter h. That's all. For me to find this big H, I need to use similar triangles, right? So if you look at it, this is one triangle and this is another triangle. Like I said, they share the same vertex. So I could just say, so for this small triangle, what is the base? The base here is the diameter of the circle, which is 16. So that would be 16 all over. This guy here is 24. Is equal to, for this guy here, this is x, right? And then for this big guy here, this is 18 plus x. So if I cross multiply, that will give me 24x is equal to 16 open brackets 18 plus x. So this is 24x is equal to 16 times 18. This will give you 288 plus 16x. So 24x minus 16x is equal to 288, and this 8x is equal to 288. So if I divide this by 8, my x is 36. So therefore my h is 18 plus 36. So plus 18, this will give me 54 centimeter, right? So this is my big H. Then my small h is 36 centimeter. That's so big. As if you look at the diagram, it's so, I mean, I'm not drawing to scale, please. So let's find the volume of this guy here. So V is 1 over 3 times 22 over 7 times R2. What is our R2? So this is 24. If the D is 24, then that means the R here is 12. So that will be 12 squared times 54. So this is 1 over 3 times 22 over 7 times 12 squared times 54. This gave me 8146.286 centimeter cube, right? So this is from the first guy, and then from the second guy, my V, so let me just say this is V1, this is V2. This will give me 1 over 3 times 22 over 7 times, where's the radius? So that would be 8. So 8 squared times, what is the h? So letter h is 36. So 1 over 3 times 22 over 7 times 8 squared times 36. This gave me 2413.714 centimeter cube. So therefore volume V is V1 minus V2, right? Talking about this, this is 8146.286 minus 2413.714, right? So this is 8146.286 minus the answer. This gave me 5732.57 centimeter cube. But they said we should leave our answers in what? In liters, right? So we know that 1000 centimeter cube is 1 liter. So 5732.57 is x liters. So let's cross multiply. So this will give us 1000x is equal to 5732.57. So basically just dividing both sides by 1000. So this is our volume is 5.7, let me say 3 liters. Did they say in many decimal places? No. So our answer is 5.73 liters. Let's see if we're correct. Great. If you notice, I mentioned another formula, right? And let me use that formula. So the formula is V is equal to 1 over 3 pi h r squared plus rr plus r squared, right? This is the other formula. So it's just saying 1 over 3, we know it as pi r square h, right? But instead of that, they said 1 over 3 pi h, then r squared plus r plus r squared. I'm sure if you do this, you have the same answer. So that will be 1 over 3 times 22 over 7 times the h, which is the height of the cone, which is 18, times so this 12 squared plus 12 times 8 plus 8 squared, right? So if I plug all that in my calculator, so this is 1 over 3 times 22 over 7 times 18 times 12 squared plus 12 times 8 plus 8 squared. So you have 5,732.57 centimeter cube. And if you divide it by 1000, you have the same value as what we have here. So whichever of the two methods you are willing to use, you get the same answer, right? If you want to go to the long method like I did here, all well and good. If you want to go to the short method, just know that it's like the same 1 over 3 pi r square h, but it's 1 over 3 pi h r squared plus small r squared plus r. Any way you choose, you arrive at the same answer. If it was the objective question, of course, this is a smarter choice to use, right? And with the theory question, you wanted to express yourself, you can use this other method. But anyway, you arrive at the same answer. Just ensure that your steps are consistent, and then you write all you're meant to write, and then you solve it to the end, right? Find the capacity in liters. So I'm moving to sphere and hemisphere. What is a sphere? A sphere is a solid figure bounded by a curved surface such that every point on the surface is the same distance from the center. This is very interesting. I think people say that the earth is not circular, the earth is a sphere, or some people say the earth is geoid, something like that. So since the sphere is a complete curved shape, therefore the curved surface area is equal to the total surface area of the sphere. It's also called lateral surface area. So this is something that you need to note, right? Since every point on the sphere is the same distance, I mean the total area of the sphere is the curved surface area of the sphere, and it's also called the lateral surface area. So there's no need for saying lateral curved surface area. No, the area of the sphere is the area of the sphere. So this is the sphere. You can see every point on the sphere is the same from the center, and it is not a circle. You can see it is not a sphere and a circle are two different things. So the surface area of a sphere, which is something as the area of a sphere, which is something as the lateral surface area, all of all those things, is 4 pi r squared, and the volume is 4 over 3 pi r cube. This is something that you need to know. While an hemisphere is a 3D geometrical object, being that it is made up of half of a sphere, with one side being flat and the other being like a bow-like shape. So this is basically what we have. So you cut it into two. You see that one part is flat and the other part is like a bow shape. You might say, oh, this is like half of a circle. No, a circle and a sphere are different. So I want you to also search and say what's the difference between a circle and a sphere. Try to find that out by yourself. So because it's half, if a volume is 4 over 3 pi r cube, this will just be half of which will be 2 over 3 pi r cube. And if the curved surface area of a sphere is 4 pi r squared, this will be 2 pi r squared. And of course, the area of the base, which is a circle, is pi r squared. Now, you can see that this is different from a sphere. For the total surface area of an hemisphere, you have to take care of the curved surface area, and you have to take care of the base area. So it's the curved surface area plus area of the base, 2 pi r squared plus pi r squared, which will give you 3 pi r squared. So these are things that you need to know. Very small, but also very important. While for a sphere, total surface area is same as the curved surface area because there is no, like it's the same points, they're all the same points. But for an hemisphere, it's different. So this example says that the surface area of a sphere is 616 meters squared. What is the volume of the sphere? Correct to two significant figures. Take pi to be 3.14. So take from NECO 2001. Assume that you've paused the video and checked that yourself. So what are we given? We're told that the surface area of a sphere is 616 meters squared. Then we should take the volume, or we should find the volume and take pi to be 3.142. So the surface area is same as lateral area, which is 4 pi r squared. So this is 616 is equal to 4 times 3.142 times r squared. So if I divide both sides by 4 times 3.142, I would have my r squared. So this is 616 divided by 4 divided by 3.142. So my r squared is just basically 49. I'm saying 49.01, but I mean, if you take the square root of both sides, you know that your r is basically 7 centimeter, right? If I know my r, I can find the volume. My formula for volume is 4 over 3 pi r cube. So this is 4 over 3 times 3.142 times 7 cube. So this is 4 divided by 3 times 3.142 times 7 raised to the power of 3. So this is 1436.94 centimeter cube. But they said we should take the two significant figures. So this significant figure, one significant figure. So the next figure is now up to 5. So our answer is approximately 1400 centimeter cube to 2SF, and that will be option C. Great. Example 10 says that find the radius of a sphere whose surface area is 154 centimeters squared. Take pi to 22 over 7. This is taken from JAMB 1993. Of course, you'll be able to solve this. The surface area, like we said, is 4 pi r squared. So this 154 is equal to 4 times 22 over 7 times r squared. Right, so if I cross multiply, that will be 154 times 7 is equal to 4 times 22 times r squared. So divide both sides by 4 times 22. My r squared is equal to 154 times 7 divided by 4 divided by 22. So this is 12.25. So if I take the square root of the answer, my r is equal to 3.5 centimeter, and that will be option B. Great. Example 11 says that the solid is a cylinder surmounted by a hemispherical bowl. Calculate its total surface area and its volume. Take pi to 22 over 7. This is taken from WAEC 1997. So for this, you can see that the cylinder, the bottom of the cylinder, which is circular bottom, would be visible to the outside world. Yes, the curved surface area of the cylinder will be visible to the outside world, and then the top of the cylinder will not be visible because it's already covered by this hemispherical bowl, right? For this hemispherical bowl, the bottom, right, when you cut to that circular bottom, would not be visible because it has been capped. Just like when you stack something over something else, you can do this. Maybe your tin of Milo and the bowl, put the tin of Milo, put the bowl on top of the tin of Milo. You see that circular place, right, would not be visible. It's just be the curved surface area of the bowl. So this will be the third part that will be visible, and it's parts that are visible that we use for the total surface area. So for here, this would be pi r squared. For here, this would be 2 pi rh. We've discussed this before, and then for here, this would be 2 pi r squared, right? So our total surface area is equal to surface area of the cylinder plus surface area of the hemisphere, and this is equal to 2 pi rh plus pi r squared plus 2 pi r squared, right? We have pi r in all of them, so that will be pi r open bracket 2h plus r plus this is 2r, right? So this is pi r open bracket 2h plus 3r. So let's substitute now. Pi is 22 over 7 times r is what? You know, we said for an hemisphere, the distance from the center to any point is the same, right? Although it's not a circle. So if distance from this middle here to this point here is r, which is 7, distance from here to this point will also be 7, 7, 7. So we already know what we're dealing with. So our r would also be true for this cylinder. Do you get? So it's whatever value from here to here, here to here, here to here. I mean, if this guy from here to here is 7, and this guy from here is 7, then for this cylinder to the top, the radius also be 7. So that's when over 7 times 7 times open brackets 2 times the h is coming from the cylinder, right? The h is from the cylinder, which is 10. Don't confuse this, it's very easy to confuse. Plus 3 times 7, right? So 7 comes to 7. So this is 22 multiplying 2 times 10 is 20 plus 3 times 7 is 21. So this is 22 multiplying 41, and that will give you a total surface area of 902 centimeter squared, right? So the first thing you need to know is that if you are given the height of a hemisphere, right, that's from here to here, which is from the middle, because the hemisphere is taken from the half. Remember, from the middle to any point is the same, just like a circle. So if here is 7, here is 7, and that will also account for the radius of the cylinder too, the cylinder top and bottom, or anyone. Now not told that, we're not told to find the volume. So to find the volume, you can see that it's going to fill up the entire cylinder, right? And it's going to fill up half of the sphere, which is the hemisphere, or the entire hemisphere. So that will be the volume of the cylinder plus the volume of the hemisphere. It's going to fill up everything. That will be pi r square h plus 2 over 3 pi r cube. You must know your formula. Remember, for a sphere, that is 4 over 3 pi r cube, but for an hemisphere, that's 2 over 3 pi r cube. So what is common in both of them? We have pi and we have r squared. So I mean, this, I could factor out pi r squared. This will give me h plus 2 over 3r, right? And this 22 over 7 times the r is 7, that's 7 squared. The h, which is the height of the cylinder, is 10 plus 2 over 3 times 7. So one of this will go. So 22 times 7, that will give you 154 over bracket 10 plus 14 over 3, right? So 10 plus 14 over 3, that will give you 44 over 3. So this 154 times 44 over 3. So if I multiply this by 154, my volume here is 2258.67 centimeter cube. The first point of mistake that you make is saying the h as 10 plus 7. No, the h only relates to the cylinder, right? It's just the height of the cylinder. That's the first mistake that you can make. And the second thing that I might be confused about is what is the radius, and I've told you how to find that. So let's see if our answers are correct. 902 centimeter squared and 2258.67 centimeter cube. Great. Example 2, which is our final question. If you have reached here and you have not liked this video still, or subscribed to our channel, a hemispherical tank of diameter which is 10 meters is filled by water issuing from a pipe of radius 20 centimeters at 2 meters per second. Calculate, correct to 3 significant figures, the time in minutes it takes to fill the tank. This was question solved by our grandfathers, WAEC 1990. So for the hemisphere, the diameter is 10 meters, right? So it's filled by a tank. Calculate the it takes to fill the tank. So for the volume of that tank, right, for an hemisphere, that will be 2 over 3 pi r cube, right? Because it's half of a sphere. So if our d is 10, then our r is 5. So our r is d over 2, which is equal to 10 over 2, which is equal to 5 meters, right? So the volume of the tank is 2 over 3 times 22 over 7 times 5 cube. So that is 2 times 22 times 125 divided by 3 divided by 7. That will give you 261.9 meter cube. Now that we have this, the next thing that we're meant to find is, I know that this is actually a very tricky question, but we've not solved something like this before. There is something called flow rate. You know, it's coming at a radius of 20 centimeters at 2 meters per second. So there's something called flow rate, right? Physics students should be familiar with this. What is the flow rate? So you know, these are a pipe, right? Our water is coming into our hemispherical tank, right? But for the source of the water, if I take a cross section, you see, and I look at the front, it will just be like a circle, right, where the water is passing. So if I take a cross section, what I'll be seeing there will just be a circle. A cross section is like slicing this place and looking at it from the front. I'll see a circle. This is what I'll be seeing from the front, right? I'll see this circle. So the flow rate is the cross sectional area multiplying the velocity, right? This is one of the formulas for flow rates. Great. So the cross-sectional area is what we are saying. The cross-section is a circle, so that will be pi r squared times the velocity, right? Our r is 20 centimeters, so 20 centimeters. We have to convert it to meters because we're dealing with meter. So that will be divided by 100. This will give us 0.2 meters, right? So that will be 22 over 7 times 0.2 all squared, multiplying the velocity. What's velocity? Velocity is 2. So this is 22 times 0.2 squared times 2 divided by 7. And our flow rate is 0.251 meter cube per second. Right? So this is what you need to know. Also, the flow rate also has another way of expressing it, because look at this meter cube per second. Meter cube is for what? Volume. So it seems like saying volume over time, right? Over time. So if I cross multiply, my time would just be equal to volume over flow rate. Right? This is a bit of physics, right? I know that this kind of question is rare, but I mean, you never can tell. So the volume is 261.9 and the flow rate is 0.251. So 261.9 divided by 0.251, that will give you 1043.426 seconds, right? But we're trying to find the time it takes in minutes, so I'll divide this by 60. So divided by 60, that gave me 17.39 minutes. But it said correct to 3 significant figures, so that will be approximately 17.4 minutes to 3SF. So what you need to know first off is that for flow rate is the cross-sectional area times velocity. If it's flowing from a pipe point, a cross-section that has a circle. Also, so the flow rate is also volume over time. So once you know those two, you are good to go for a question like this. Let's see if we're correct. Great. So 17.4 minutes to 3 significant figures. I'll see you in the next video. Bye for now.